Hey guys, welcome to question MM419 of the Maths Methods Fortify study guide. So in this question we've got Cal's alarm clock is broken, so it doesn't always work. Now the probability that Cal gets to work on time, given that his alarm goes off, is 0.8. Okay, so what we're saying is if his alarm goes off, he's got a 0.8 chance to get to work on time. Now, and the probability that he gets to work on time, given that his alarm does not go off, is 0.3. Okay, so if his alarm doesn't work, he's got a 0.3 chance to get to work on time. Now, Cal's alarm only goes off 70% of the time. Find the probability that on any given day, Cal gets to work on time. All right, awesome. So what we know is that we've got some dependent probabilities happening here, so some conditional probability. And whenever we've got an event that affects something else, that's when we want to draw a tree diagram, because we're going to have to use conditional probability. Okay, so whatever affects the other thing, that's what our first branch in the tree diagram is going to be. So in the morning, Cal's alarm either goes off, as in it works, or it doesn't work, okay? And then if his alarm goes off, he either gets to work on time, or he doesn't get to work on time. Same as if it doesn't go off. So if his alarm does not go off, then he either gets to work on time, or he doesn't, okay? Now he's got 70% of the time his alarm works, which means that we've got a 0.7 chance for this alarm to go off. Because we've got a 0.7 chance for it to go off, that means we have a 0.3 chance for it not to go off, right? Because these two have to add to 1. Now, if his alarm goes off, he's got a 0.8 chance to get to work on time. If it doesn't go off, he's got a 0.2, okay? Because these two have to add to 1 again. Now, if it doesn't go off, so if his alarm doesn't work, he's got a 0.3 chance to get to work on time, okay? So 0.3 here. Now, if it doesn't go off, that means that he has a 0.7 chance to not get to work, okay? Because he's got a 0.3 to get to work, so a 0.7 not to get to work. Now, what we're looking for is the probability that he gets to work on time, regardless of whether his alarm goes off or not. So, in order for him to get to work on time, his alarm could go off, and then he could get to work, or his alarm could not go off, and then he could still get to work on time, okay? So this is actually our first mark right here. What we're looking for is the probability that he gets to work on time, right? Which means that we can get the probability that his alarm goes off and still gets to work, so AT, or the probability that it doesn't go off and he gets to work. So probability A-T. Awesome. Now, in order to figure out these probabilities, we simply need to multiply these branches together. So 0.7 times 0.8 plus 0.3 times 0.3. Awesome. Now what this gives us is 0.65 in the end. And that's our second mark. So 0.65 chance to get to work on time, regardless of whether his alarm goes off or not. That's our second mark for part A. Guys, let's move on to part B. Part B asks us to find the probability that Cal's alarm goes off, given that he doesn't get to work on time. All right, awesome. So immediately we can see we've got this given formula, right? So we know that our probability of A given B equals the probability that A intersect B over the probability of B, right? So what we're looking for here is that his alarm goes off, so the probability that his alarm works, given that he does not get to work on time, all right? So this is equal to the probability that his alarm goes off, intersect, doesn't get to work on time, over the probability that he does not get to work on time, okay? So the intersect, in a tree diagram, the intersect between two things is just the probabilities of those branches multiplied together. So the intersect of alarm going off and not getting to work on time is this path here. So this one, which means that the probability is 0.7 times 0.2 over the probability that he doesn't get to work on time. Now in part A, we figured out that the probability that he does get to work on time, let's get rid of that, the probability that he does get to work on time is 0.65, right? So that means that the probability that he doesn't get to work on time is 0.35, right? Because it's 1 minus 0.65. Now this is actually our first mark down here. And then our second mark is given by 0.14 over 0.35, which is 14 on 35. That's our second mark there. And that's it. So guys, 14 on 35 is our final answer for part B of MM419. Guys, if you have any questions about this, please hit me up in the comments below. But otherwise, thank you very much for watching, and I'll see you in the next video.